Alright, here we're going to learn about solving two-step equations. So you should have learned about this last year, so this should just be a review. We're going to eventually extend this into solving multi-step equations and then solving equations where there's a variable on this side and a variable on that side. Right now we're just solving two-step equations. So an equation is saying that this side equals that side. And for that to remain true, we can perform operations on a side, but we have to do the exact same thing on both sides. So if we're going to add something on this side, we also have to add it on that side so that this remains equal. And while we're doing that, our whole agenda, the entire point of this, is to get x completely by itself on this side. So we're trying to cancel out any operation that's happening to this x right now. So right now it's being divided by 4, and then we're subtracting 3. We're trying to cancel out those operations so that we get x completely by itself. To do that, we're going to put a box around the x term, so anything that's being multiplied by x, or if x is being divided by a number, we're going to put that in a box. And really what that's saying is that we're going to cancel out whatever's not in that box first. So I'm going to draw a line down the equal sign. We put a box around our x term, and then we're going to deal with this number first. Whatever's outside of that box, that's what we're going to cancel out first by using inverse operations. Inverse, that word really means opposite. So the opposite of adding is subtracting, opposite of multiplying is dividing. We're going to use the opposite operation of whatever we see to cancel out the operation that's happening. So right now we're seeing a minus 3. To cancel that out, we do plus 3 on both sides. Minus 3 and plus 3 cancel each other out. If we do it on this side, to keep this balanced, we also have to do it on this side. So we're going to add 3 on that side. That's where this 5 is coming from. 2 plus 3 gave us 5. This comes down. That's the only thing that's left on that side because that just canceled out. Now we have x divided by 4. So to cancel out this division, we're doing the opposite of dividing by 4. We're going to multiply by 4. If we do it on that side, we have to also do it on this side. So we do 5 times 4 to give us 20 as our final answer. These canceled out. The only thing left there is just that x. So the x comes down, and then we multiply on that side to get our final answer of 20. One really nice thing about this is that we can always check our answer to make sure that we're doing this correctly. We're going to substitute this answer back into the original question. In place of that x, we put 20, and then solve this side. We're just going to use this side. I would type that whole thing into Desmos. I mean, you could also follow order of operations, but Desmos makes sure that you're doing it correctly. 20 divided by 4, that's 5, minus 3, that is 2. So we did that one correctly. 20 is the only solution to that equation. It's the only number that would make this side equal to 2. You can always check your answer when you're solving an equation. You plug it back into the original equation, make sure the left side and the right side are the same number. Alright, so we're going to show that a few times. One thing that I'm not such a fan of is that these steps actually don't always work. Putting a box, I mean, in general they will work, but putting a box around the x term will work in most situations. But then when you get to an example like this, it actually doesn't apply to that example. We're also going to see in this example that we're not really going to use an inverse operation. I'll show you that in a sec, but these are not perfect steps. It's just general guidelines on how to solve an equation. Remember, the goal is to get the x by itself. So we want to cancel out anything that's happening to the x on this side right now. So I'm going to put that 4x in a box, and then I'm going to cancel the thing that's on the outside of that box, this minus 7. Right now it's subtracting 7. You want to do the opposite of minus 7, so we're going to do plus 7 on both sides. That's going to cancel it out. That's exactly what we want. That leaves us with just the 4x on the left side. And then on the right side, I'm going to actually add that 7 to this negative 15 and get negative 8. Now I see that I have multiplication. It's 4 times x. So to cancel out that multiplication, I'm going to divide by that number exactly. If this was a negative, then you divide by negative 4. It's positive, so I'm going to divide by positive 4 on both sides, and that would give us that x is negative 2. Now remember, we can always check our answer to make sure that we're doing this correctly. We take negative 2 and we replace the x with it. So instead of that x, we're putting in negative 2. And then we're going to figure out what this equals to make sure that it actually equals the right side. So 4 times negative 2, that's negative 8. Minus 7, that is negative 15. So we did that one correctly. do the same thing on number 2. I'm going to box my variable term, and I'm going to include the sign with it. That's really important. We have to include that sign because that's a part of this term. So I'm going to box it, draw a line down the middle, just to make sure that I do the same thing on both sides. Whatever I do on this side, I have to also do on that side. So I want to think about how I can get this by itself. Really, how can I cancel out this positive 4? That's a positive 4. I'm going to do the opposite of a positive 4. I'm going to subtract 4 from both sides. Those will cancel each other out. If I do it on this side, I also have to do it on that side. So I'm going to subtract 4 from this negative 8. That would give us negative 12. This is the only term left on that side. So that gives me 2/3 n equals negative 12. Now I want to try to cancel out this multiplication. So this is where that second step isn't exactly what I would do here. You could. You're allowed to do this. I wouldn't write this part down. I'm going to show you a different way, but you can divide by 2/3 on both sides if you want to. This is not exactly how I would do it. It's going to work, but this isn't really how I'm going to show you. I'm going to show you a different way to cancel out this 2/3. We're going to flip this fraction upside down. We're going to multiply by what's called the reciprocal of that fraction. You flip that fraction upside down and multiply. Those are going to cancel each other out. If you do it on this side, you have to do it on that side too. So we're going to multiply by 3/2 on both sides. Those cancel out. Leaves me with just n. And on this side, I'm actually going to multiply, and that would give us negative 18. So anytime you see a fraction like this, if the coefficient is a fraction, you can multiply by that fraction flipped upside down to cancel that out. Now I'm going to take that negative 18 and check to make sure that my solution is correct. Negative 18 times 2/3, that's negative 12. So that turns into 4 minus 12, which is negative 8. So we did that one correctly. Same thing here. I'm going to box my x term, including the sign. I'm going to put that part in a box, including that minus sign. So you might be thinking, since I see a minus sign, my first step has to be addition. But that's not really true. If I add 4 to this side, that wouldn't cancel that out. If I add 4 to 4, that would become 8. I have to think about how to cancel out a positive 4. I'm going to do minus 4 and minus 4 on both sides. 4 minus 4, those cancel each other out. That negative x is going to come down. And then 9 minus 4 gives me 5 on the right side. I have one last step here. Right now, I have a negative sign in front of that x. So really, I have a negative 1 in front of that x. Negative 1 is being multiplied by that x. So to cancel out that multiplication, I'm going to use division. Divide by negative 1 on both sides. Multiplying by negative 1 and dividing by negative 1, those cancel each other out. That gives me x all by itself there. And then 5 divided by negative 1 is negative 5. So negative 5 is my final answer there. All right, now number 4, the boxing method kind of falls apart. Because if I box my m term, the only thing I would put it in a box is really that m. Not that helpful. Really what I want you to think of here is order of operations backwards. Don't write this part down. But let's say I had 10 in place of that m. It's not the right answer. I'm just saying I put a number there. I want you to think about what order of operations would suggest we do first there. So order of operations would say that we do this as our first step. Solving an equation is working order of operations backwards. So that means that is going to be the last thing that we deal with. So this is going to be our first step. So I want to think about how to cancel out that negative 3. Right now, that's showing that we're dividing by negative 3. You always need to think about the operation here. Even though it's a negative 3, you might be thinking we're adding, but that's not really going to cancel out division. To cancel out dividing, we have to use multiplication. Dividing by negative 3 and multiplying by negative 3 cancel each other out. That leaves me with just the stuff on top. M minus 2 equals negative 3 times negative 6 is positive 18. One last step here, m minus 2, I have to do the opposite of minusing 2. I'm going to add 2 to both sides, that gives me 20 equals m. You can write it as m equals 20, or really just 20 is our solution here. Alright, actually the skills that come with solving two-step equations, I feel pretty confident with. I think your teachers last year did a good job of teaching you this. I think word problems and these pictures that go along with these equations might be the most challenging part. So we're going to use that diagram to create an equation first and then determine the value of x. So first I just want to write an equation to represent what I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I have these minus x blocks. I have 2 of those. So I have 9 minus 2x. That equals 3 on that side. So that equation represents that picture. Now I can use the steps to solve it. I'm going to box this, including that sign there. That is a part of this term. That's a minus 2x or negative 2x. You have to start seeing it as a negative 2x there. I want to cancel out this positive 9. I'm going to do that by subtracting 9 on both sides. Positive 9 and minus 9 cancel each other out. The negative 2x is going to be the only thing left there. I'm running out of room, so I'm just going to write it over here. Negative 2x is left there. And that equals 3 minus 9 is negative 6. I have one last step here. I have multiplication. That's being multiplied. So the opposite of multiplying is going to be dividing. I'm going to divide by that negative 2 on both sides. That's going to give me x equals negative 3. Sorry, positive 3. It's a negative divided by a negative, so that's positive. Actually, that should make sense. If this was negative 3, that was negative 3. 9 minus 3. Minus 3 again would take us down to just positive 3. Alright, now we have 3 word problems. So we're going to determine the equation that would be used to solve that word problem. Miss Hart painted the interior of her home, and she used 12 gallons of paint and spent $182 on supplies. If it cost her a total of $289.88 to complete the paint job, how much did each gallon of paint cost? This question is telling us where our x is. That's the thing that we don't know. That's the variable. That's what we're looking for. We don't know what that equals. That's why that's the unknown amount or the variable. So we don't know what each gallon of paint costs, but we know we bought 12 gallons of paint. We know these two have to be attached to each other. Each gallon of paint, 12 gallons of paint. It's going to be 12 times some amount of money. So just based on that, I can rule out this one. This would be saying I bought 194 gallons of paint. That's not true. Next thing I'm going to look at is this total. I see it's going to be a total of $289.88. So the total, that word total, that's where your equal sign is. So it equals a total of 289.88. So it could be one of these two. This seems like that's flipped. The 289.88 should be on this side. So the last thing I have to decide, am I adding or subtracting? When you spend money, you might be thinking that's got to be subtraction because you're losing that money. But really, we're spending all of this money. You're spending money on the paint. You're spending money on the supplies. We're adding those two together to find the total. So it has to be that equation. 12 times however much the paint costs, plus the supplies, adds up to a total of $289.88. All right, now the last two, we're going to set these both up and then solve the equation. So Sean earns $21 per hour working as a truck driver. This phrase per hour is really important. That's telling us that's where multiplication's happening. He earned a total of $1,114, which included a food allowance of $250. How many hours did he work last week? So how many hours? The question is always representing the variable. Actually, I'm going to change that variable into an h because we're talking about hours. But the question part, that last sentence, is always going to tell us where our variable is. How many hours? That's the thing that we don't know yet. This part is also really important. It's telling us it's $21.60 per hour. That's telling us where the multiplication's happening. So it's $21.60 times some number of hours. That's how much he's making working as a truck driver. And we know it's going to be a total of $1,114. I know that's going to be at the end of my equation. It's going to equal that total. So now I just have to decide what operation is going to happen with this $250. So we know we're making some money as a truck driver. and we're getting a food allowance of $250. We're adding in a food allowance of $250 to give us a total of $1,114. So now I'm going to solve that equation. I'm going to draw my line. I'm going to box this term. So I'm going to start by subtracting the $250 from both sides. So I have $21.60 coming down on the left side. And then on this side, I'm just subtracting. Those cancel out. That's why the $250 is gone now. That gives me $864 left over on the right side. One last step, that's multiplication. So to cancel out the multiplication, we're dividing by 2160 on both sides. So H is 40. So Sean worked 40 hours last week. So he worked 40 hours to make some amount of money as a truck driver, plus he made some money from the food allowance. That gave us that total of $1,114. Same idea. We're going to set up an equation and then solve it to solve the problem. Piper bought a car priced at $3,995. She paid $350 as a down payment and then plans on paying the remaining amount over the next 18 months in equal payments. Equal payments, the word each, the word per, all of those mean the same thing. We're splitting it over those equal amounts. Really, we're multiplying 18 times that amount of payment. So it's going to be 18 times, let's call it P, that's the payment. Those are these equal payments. Plus, we're starting off by paying $350 to give us a total of $3,995. We start by paying that, plus we're going to pay $18 times the same amount each time. Actually, another way I've been stressing, how much money will she pay each month? That's where our X is, or in this case I use P, but that's where our variable is going to be. That's what we don't know yet, how much they're going to pay each month. Now we can start solving. I'm going to box that 18p. I'm going to subtract $350 from both sides. That gives me $3,645 left over on the right side and 18p on the left side. Last step, that's multiplication, so I'm going to use division to solve. That gives me that each payment is $202.50. So we pay this 18 times plus the down payment, gives us a total of about $4,000 for the car. Exactly what I did on this problem, I would recommend that you do that on each of these. Highlight the important information, anything that's attached to a number. Think about how that's going to be written in the equation. The question is always going to show you where your variable is. All right, I hope this helps you.